Okay, so let's welcome Karl and David on stage with their talk about the Sling Feature Model revealed. Welcome, Karl and David.
We can also call it PowerPoint revealed. Ah, there it is.
There we go. Hello. Does it work?
Ooh.
Hey. Okay. So yeah, welcome to our talk today. For those that remember, and for those that don't, I can summarize it again. So 2 years ago at adaptTo, Dominic Süß and I started talking about the feature model prototype that Carsten started working on. So he's a mastermind behind of all of this, even though he never talks about it. But it's his fault. And back then it was some implementation there and some concept, but not yet really fully usable. And since then David joined, and we worked on it both internally at Adobe, but also on the Sling side, and finished the concept and polished the implementation some more. So we had a talk last year together about basically the final model. I think there would have been very small tweaks to it since then, but it was already the final model, but the tooling wasn't fully implemented yet, and we made quite some advancements there, and there's an extension model built into all of this, so we added extensions and made all of this work. So we figured it would be nice to have at least this one more talk this year to put it all together, and so that's what we try to do today. We don't have slides for ourselves, but that's David Bosschaert. I'm sure you know him by now, and I'm me. We both had talks, so I think we don't need to reintroduce ourselves. So we're going to first talk about the feature model again, now in its final form, how it looks, what extensions we have, what is there. Then I'm going to talk really quickly a little bit about the tools and show a demo. It's going to be based on, or at least, or maybe better, it is the same stuff that I had with Radu in our talk on the first day. So if you want to fast forward and are bored, you can already start playing again with the example code we had there, but I'm going to zoom into it and explain the feature model related parts of it. And then we come back, and David gives us an update of where we stand with standardizing all of this in OSGi.
All right. Okay, so the feature model, and why? So let's say you're building an OSGi-based application, and you're very, very happily building it. You've got some bundles. They kind of work together. You have some configuration, and you add some more bundles, and some more configuration, and your OSGi application is working great. More bundles, some metadata, and so you're very happy with it. And then you give it to your colleague because you're going on holidays, and he says, what is all of this doing? I don't understand it anymore. It's just too much stuff there. And obviously this slide only has like 7 bundles, but in reality OSGi applications can have hundreds of bundles, and it's kind of hard to kind of fully understand what they all do if you have just the bundles, and also like if you have separate concepts like configuration and metadata that might sit in separate files. So this is really what the feature model is about. Instead of having individual bundles, you have like a chunky feature that contains all of these bundles and their configuration, and it's even extensible so that it can contain your custom metadata as well, all together, and then you can just put a bow on top and finish it off all together in itself. It's self-contained. And once you've created this feature, you can start reusing it. So let's say I'm building a kind of a web service somewhere, And I need, for that, I need JAX-RS, I need a HTTP service, I need a database. Instead of having to kind of find all these things together myself, I should be able to just pick the features that provide this kind of functionality by referencing them through Maven artifacts. So I have like a JAX-RS feature, I have a HTTP service feature, and I just point at them, and I have my own code, which is like a couple of bundles maybe that provide my own web service. And then basically I kind of put this in the grinder and create my own distribution. And that's what the aggregation process is about. It's about, you know, combining features that are potentially independently created and combining them into a single feature, which you could call distribution, and merging them, because there's likely going to be conflicts if you have these features that are independently created. They probably have similar dependencies, maybe in different versions. These things have to be merged so that you don't end up with 5 instances of the logging service, for example. And this is what the aggregation does for you. And then once you have your distribution, you can run it. Or you give it to someone else who can embed it again in a bigger kind of application. So the aggregation or the merging is one of the things that is done by the tools. Another thing that happens typically, you know, around the same time as the aggregation is the analyzing of your features. There's a whole bunch of analyzers that can look at whether your features are transitively closed, whether you're following best practices, and so on. And it's pluggable, so you can create your own analyzers that do something special that is important to you, and so that you can do all this at build time, which makes the startup quicker because you don't have to do it at runtime anymore, and it also makes the system more predictable because you know it during your CI/CD. And another thing that is worth mentioning is that because features are extensible, you have your own kind of metadata in there. This metadata might require special handling, and again, the merging phase allows you to plug in merge extensions that allow you to implement your own special handling for this special metadata. Okay, so you've got your distribution feature. This is my application. It's maybe Sling with my super cool web service on top. You give it to the launcher, which is another tool. It's a jar file. You just call java-jar launcher.jar, something like that. You give it the feature, and up comes your system, and it's up and running. So that's all really nice and simple. Now, in some cases, you might not be able to specify all the information in the feature file up front. For example, the API key, the one that Karl showed there yesterday, I copied it over in case you didn't get it yet. Yeah, something like an API key or a host name or a username or something like that. This is typically something that you don't want to hardcode in the feature file because it will change from instance to instance. So the feature model supports variables, and those variables can support late binding. You can provide them at launch time to the launcher. Another interesting thing is that, let's say you have your distribution, you have your product built using features. A user has a problem with it because maybe they're running it on Windows and nobody ever tried it on Windows before, something breaks, you'd like to investigate what's going on. Now, a good tool to investigate OSGi-based applications is the web console, but you didn't happen to include that in your product because normally people wouldn't really need that. So what you can do is you can actually give multiple features to the launcher. So you can say, okay, I want that my distribution, but I'm also going to give it the web console feature. You launch the two of them together, the launcher will merge them on the fly, and all of a sudden you have this web console available in your feature as well, in your runtime. So it can be really handy for certain kind of use cases where you need to enhance the product or your component for certain situations. Okay, so that's just the kind of the overview. Also wanted to briefly mention like the world in Sling, the world of the feature model. We have a whole bunch of Git repos in Sling. There are 5 main ones, which is the feature model API and the JSON serialization of it. We have an analyzers repository. We have the launcher, and we have the Sling Feature Maven plugin, which is basically the primary Maven tool. There's also a whole bunch of other components. There's a converter that converts to and from the old Sling provisioning model, which can be useful if you want to use them side by side. We found that authoring in the feature model first, so let's have the feature model be the source of record, and then converting back in the provisioning model works really well. The other way around is not as expressive. So I would recommend the feature model as the base. I think we're going to do that in Sling as well, as switch over to feature model. We have like components that basically produce a feature from your current runtime. So if you're running Sling and you want a feature from what that runtime is, this component can provide it to you. There's also a component that can provide the diff between the feature that was launched and what you are running. So let's say you launched a feature, you made some changes to the configuration, or you added some bundles. With this tool, you can actually generate a new feature that is what your system has become after your changes. So this can be useful for during development, for example. Some integration with the inventory printer, which is a web console component. There is a component that handles content packages and repo in it. There's a converter to Carafe, so features to Carafe features converter. And there's also some components around what is called API regions. Now, API regions is something that is probably we could spend a separate talk about altogether, but it's really about limiting the public surface of your system. So typically, OSGi-based applications are open applications. They allow custom content to be installed or custom bundles to be installed. And maybe you don't want your public API to be public to everybody. Maybe you only want to be available within a certain region. API regions is all about that. It's about limiting the public service of your components. So those are the kind of the components. They're all in Sling as separate repositories. I have a link at the back if you're interested to take a look. Now let's have a quick look at what actually the feature model typically looks like. Normally the feature model is expressed as a JSON file. It has an ID. In this example, it has a variable. In this case, it's a HTTP port, which defaults to 8080. But if you want a different one, you can specify it on the command line using -v. We have 2 bundles listed here and a bit of OSGi configuration. So this is like a very basic feature that you could use to have the OSGi, the Felix HTTP runtime, which is based on Jetty. Okay, and then let's talk a little bit about the Sling Feature Maven plugin. It has a lot of targets that you can use. There's a few that I want to lift out here. It supports this aggregation. So with this, you can basically select multiple feature files. They can be in your project. It can be out in a Maven repository. It supports all that. You can combine them all together and merge them. Either to create intermediate features or to create self-contained kind of runnable features. And they also support these custom merge extensions where you can basically influence the aggregation process. So that's really kind of powerful. With the Sling Feature Maven plugin, you can also execute the analyzers. You select either all of them or the ones that you want to run. Currently, all the analyzers are in one Git repo, but you can also add your own in different Git repos. We have bundle import and export checkers, requirements and capabilities checkers. So for example, if you have those, you can check whether your feature is transitively closed. If it's not, then you will get an error message and the Maven build will stop. There's also for Sling content packages, if they have a dependency on another content package which is not available, similarly it can be checked. There's an OSGi Connect checker, which is super cool. Except I don't know what it does, but maybe Karl can explain it later. And there's an API regions checker, which basically checks that your API is not violating those regions and is not looking at stuff that it's not supposed to see. And then finally, there is a target that creates a repository of all the artifacts mentioned in your feature. So your feature has, maybe you've got your whole product from a bunch of aggregated features. Now you want to put it in a Docker image, something that Karl is going to show later on. You don't want that Docker image to have to go back to a Maven repository to fetch all those things. No, you want all those things pre-baked in a Docker image so that it has everything it needs. And this repo target can do exactly that for you. And with that, I'd like to give it back to Karl.
Right. So Exactly. I mean, I think that is an important point in all of this. So on the one hand, the whole feature model idea is to allow bigger aggregates than bundles, right? With different things in them, because bundles only modelize you that far. But on the other hand, from the get-go, it had the aspect that the idea was that you want to be able to create a system and then run it, right? So take away up to a point the runtime dynamism that OSGi allows you to have, where you install bundles and they come and go, but just build the system once, configure it when you start it, right, and have it running. And that obviously was an anticipation or with the idea in mind that we eventually will move to and support the Docker world, where that's just the default, right? You build your image, everything is in there, and then you start it up, and then there might be some late changes to configurations and things in it, but other than that, you don't want to have it changed, right? It is an immutable thing. So that's really where it's geared towards, and that's why we have that launcher, which is still using internally an OSGi framework for launching everything. So the full capabilities are still there. However, it is pluggable, so you could use something else in the OSGi framework to launch the end result, which is in this case the checker for the OSGi Connect is going back to what I mentioned in the talk with Radu as well, the old idea to have an OSGi framework that's not dynamic, effectively, and it only uses one class loader, but it has limitations. So the OSGi Connect checker that he mentions for the analyzers checks whether your application could actually run in such an environment. That's where it's coming from. But yeah, so we have the launcher, which is responsible for all of that. So it is responsible for selecting a framework. Could be an OSGi Connect framework, which has limitations. Could be a full-blown framework. The launcher doesn't necessarily care because it doesn't take any of the dynamism into account. So it will take your features that you want to run. It will extract the variables and framework properties out of the features, and then look at the variables and say, okay, do I have values for all of them? Because you can specify them with the null to say, well, they need to be provided at launch time, or they have defaults. So okay, then I take the defaults. It will do the processing of all of that, merge the features together that it gets. That was the late merging feature that David mentioned. So if I have an extra web console to put in, it will do some late merging. Then it will look for the artifacts, either in remote repositories if you gave it some, or in the local one. And if it has all the artifacts, well, it will install all the artifacts in the framework, install all the configurations in the framework, and start up. Right. So a special thing is we also have extensions that you can give to the launcher. So if you want to do some late processing or some processing of your custom metadata that you had in features, you can. You have to give them as jars on the class bus to the launcher. Then it will just call you before it started the whole thing so that you can process them. We're not going to show too much about that today because it's getting too complicated to get in a half-hour demo, but it's possible. And things like, for example, the mentioned package init, so the content handling, which allows you to have content packages in your features, is done as extensions, right? So they're not part of the core; they're just external features. So if we want to use it in practice, then what the typical way is that it's envisioned or used is you basically use the Maven plugin that David mentioned to create a repository locally. And then you take that repository and you wrap it in a Docker image. I say here, base it on Java 11. You can base it on a Pine. You can J-link stuff because we just then use the Java command to use the launcher to start the whole thing. Again, the launcher can be used to optionally merge scripts and has the config admin in memory and does the extension things. And then ultimately you can launch your Docker image, and that still works reasonably well with layering of Docker images too, because we don't only have the features that can be parallel, but you can also have the Docker images in a hierarchy. So I will show that a little bit, how you can do that in a good way right now. Again, the link is here again. That's the same repository we had in the first talk with Radu, because I'm going to show how that demo that he showed actually is implemented. So if we go if you go and check that out, you will see, well, we have several projects in there, so it's a multi-module thing. We had the resource provider for Dropbox and the actual abstraction down here, but we don't need to think about that right now. And the demo content, we don't have to think about that either. But we have as a core the Sling Mini project here, which generates a Docker image of a minimal Sling system that can be started in a Docker image. Right, so that's the minimum. The way that works is you put a source main features folder in your Maven project and put features you want to have as JSON files in there. We have here the feature JSON, which is the main file of this project. It looks big because it has all the bundles that you need to start a minimal Sling listed in here. We only actually need one configuration in that case, which was specific to it because we don't want to have JCR in this. So we set the provider names to 0 or to remove the required providers. And we give it some framework properties as a section in the feature. So we basically here, we can switch the configuration admin into a feature launcher mode, which means it will not persist its configurations. We give it some boot delegation. We set the framework parent for the class loader, and we configure a property that one of the bundles can pick up later. I will mention what it does, but it's a config admin plugin we will use later on, and it needs some environment config. So we set this in this one as well. We defined 2 extra features which can be optionally used. One gives you some more Java things wrapped from Geronimo with 3 bundles. And then we have another one which is for the web console because that can be optional, right? You may want to use it or you don't. And then the way we handle that is in the POM. There we use the Sling Feature Maven plugin. Well, in the one example here, we use the aggregate feature that David mentioned. So here we just say, well, we want to, if you need it, we give you a full feature which will merge the 3 features that I mentioned together and attach it again as a feature which is a classifier of full. Right? It just takes all features that you have while we attach the features. And here is the mentioned create repository goal. So that allows you to give a classifier. In this case, we take just all classifiers because we want all artifacts, and it will then get all mentioned artifacts in those features and create on disk a directory which has all the artifacts in it. Right? We can embed extra artifacts. In this case, we make sure the Felix framework we want to use is in there as well, so that we have that. But that's pretty much already it. We also copy a launcher someplace. I'll show you in a second why we do that. But for the most part, that's all we need. And then we just invoke the Docker Maven plugin to create us a Docker image. And for that, it just takes the Dockerfile that is in this project. The Dockerfile is reasonably simple. It is based on Alpine 11 from the Java 11 on Alpine from ASUL, because they support that. Then we have a little bit of preparation work where we just run a JLink to JLink together the minimal Java runtime environment we need. So this is a list of Java modules we want. That's, again, optional. You could just use a full-blown Java JDK if you wanted to, but then it's obviously bigger. There's a little bit of prep work here to create a user, but other than that, that's the important part here. We basically take the artifacts. We just generated the artifacts directory so that we have all the artifacts we want to put them under opt-app artifacts. Then we copy the launcher that we got so that we have the launcher version we want to use from the feature model. And we take the actual feature that we generated because that's the one we want to run. And from there on, we just invoke Java with the launcher. So it's a feature launcher here. And we point it to where it can find the artifacts. Again, this -u, you could give it a list of URLs that can also be just remote repositories, Maven repositories if you want to. But for the Docker setup, we want to have everything locally, right? So that we just point it to the artifacts we generated. And then we give it the feature file that we copied up here. And so, yeah, if that gets started, it will just run that feature file. And that's it. Then because of lack of time, I fast forward a little bit and not show the minimal setup, because that was just the plain Sling that you get generated here. We had a second project, which actually is then our mini demo project here, which again defines a feature, which adds all the bundles that we had for our demo, and the current project bundle as well, right? So it's not that big as I thought, maybe a little bigger. And the bundle that we had is in here as well. And we had another feature, which is just basically only a configuration. And David showed it a little bit already, but this is the way you can make the configuration in OSGi look back at variables. We can define variables in the feature, so that tells the launcher that it can replace it when it starts. And we define one for the Dropbox access token. And then we can just reference it in our configuration, which will be provided as an OSGi configuration, as a $Dropbox access token. And there's a specialty here that's a little bit more complicated, because what we set the value to is yet another reference syntax, a $secret Dropbox access token. And that was the configuration I showed before. It's a special plugin from Felix nowadays, which allows you to reference values from a file on disk, and it's mostly used for Docker environments and Kubernetes environments, where you can put, just like in this case, an access token, so you don't have to do what I did in the other demo, namely copy and paste in plain text. The access token, we can just put it into a file. So basically this tells it, okay, at runtime go out, look at the file on disk in a directory which is called Dropbox access token, take the content and put it into this configuration at the last minute at runtime. So with that, then we can go again, have a POM for this, where we use the Sling Feature Maven plugin again to aggregate the features together. So we at the one hand use the Sling Mini feature we created in the first step, right? And these features we have in here to create the feature we want to ultimately run, including the demo bundles and the Dropbox token setup. And we have done that. We also need to do another create repository, so that we get the artifacts from this project, from the mini demo, right? It's the demo bundles. We want to also get them on disk in a folder. So we just tell that to the plugin. And then again, we just invoke the Docker Maven plugin for its Dockerfile. And it's here. And so the idea here is then, and that's the layering where we can, so we did the layering on both levels. We once used the Sling Feature Maven plugin to just merge our local demo features together with the Sling main feature. And on the other hand, now we're going to use layering on the Docker level to say, okay, well, we already created the base image in Docker, so we just inherit from that one. And then also we need to do is copy over the extra artifacts from our demo, from the target artifacts, into the already existing artifacts from the base image. And we need to copy over the new feature file. And in this case, yeah, I mean, I'm not sure what the best version is to do it. We copy just over the other feature file, so the launcher command doesn't have to deal with different feature files. I mean, you could have other mechanisms in place here. So with that setup, all we need to do is build it. And we didn't show it in the other demo, but I built it here already. And so we end up having two Docker images. We have the mini Docker image, which is a base image. It's only 65 megabytes big. And then we have the one that inherits from it for the demo, and that is 74 megabytes big, right? So these are the two minimal Sling that you need with only web console, and the same plus our demo images from the first talk. And then we created a Docker Compose file here that you can use to start it. And as you can see, it just takes the demo app and an Nginx, but it also mounts in a file for the Dropbox access token, which you can have locally, and then via this variable resolution I showed, it will eventually find the Dropbox access token in this file. All right. So, and since we're running out of time, that I don't have to actually show that it works. You just have to trust me it does. Right. So with that, Right. So that was the demo, and the code is again at the old repository. Link is in the slides, but you can always look at it.
And Karl showed me yesterday that it works, so you can trust me too. Okay, so really quickly, so we're proposing the feature model as a specification in the OSGi Alliance. Obviously, a lot of the work is done in Sling, but similar projects have done similar things in other communities, like Karl has something, Eclipse has something, companies have something. We hope that the feature model becomes like a portable exchange format that can control all of these technologies. So the RFP in OSGi has been accepted. Currently, the RFC is in progress, is under discussion, and the link is here. So yeah, I'd like to invite everybody to get involved on the Sling level. The feature model Git repo is listed there. There's a whole bunch of other ones. They have similar URLs. You can probably find them by looking at around GitHub or the Gitbox in Apache. OSGi also has feedback channels, so if you want to kind of provide feedback on Sling, you can do it as a pull request or on the mailing list, or you can provide feedback to OSGi, or you can even join OSGi, the face-to-face meetings or the discussions of the RFCs directly. So I just want to mention that that's also in progress.
Right. And I think it's important just to point out from a AEM perspective, we might hear a little bit more in the next talk, which is by Tomek, who zooms into what we do internally.
Okay, I think we're a little bit over time. Do we have time for a question, or?
Yeah, if there are questions.
Hi. Besides the feature launcher, will there be something like a feature deployer, which I can, I start minimal Felix and deploy the feature deployer bundle and deploy a feature to rise it up?
Well, as I was trying to say, I mean, the focus and the idea was to cater for cases where you control everything, right? So the launcher would start the framework, provision it, and start it up, and that's your system. And if you want to change it, you would stop it and redo the whole thing and come up like that. So from that perspective, there is nothing like that right now. I know that that's in Karl, for example, Karl features, that's more their model because that was the way they designed it. There's nothing technically that would stop you from doing something like that. You just would need to take what's available to parse existing features and implement it, basically, right? But right now, there's nothing that does it for you out of the box.
I guess it would be really useful for development if you want to develop features to do these things. But I guess especially in a world of Docker where things are immutable runtimes, you want to kind of know exactly what you're launching, right? Well, maybe you have an entirely different use case, and then obviously the Sling community is open.
Well, coming from the old OSGi world, it makes perfect sense. However, you gotta, sometimes it's a question of resources that you have to do something like that, because it's a little bit of a pick your poison situation there. Because once you start that, you have all the runtime questions, right? What happens if you install a feature? Well, can I uninstall the feature? What happens if there's conflict? Can I resolve those? What happens then if so there's a whole can of worms around that, which we just skip by saying, well, we don't support that right now.
Okay. Any other questions? So then thank you, Karl and David, for your talk.